My name is Anna Tenpencil. Welcome back to my channel. I am going through as many LeetCode problems as I physically possibly can in a year, and you guys are here for the journey. I am on question number 90 for the binary tree in order traversal, and this is supposed to be easy. And they say that, but I feel like I genuinely think they might mismark some of these questions, or my brain just thinks in weird sorts of patterns. So let's jump into the solution, which today is in Python, and let's hop to it. So this is, again, question number 94, binary tree in order traversal. Given the root of a binary tree, return the in order traversal of its nodes' values. So example, 1, 2, 3. The root is 1, null, 2, 3. So 1, 3, 2. This one, it is nothing, and then this one is 1. The number of nodes in this tree is in range from 0 to 100, and then they give us this additional constraint down here. Follow-up recursive solution is trivial. Could you do it iteratively? Life's persistent questions. Yeah, I think I can do that iteratively. It might not be as pretty as a recursive solution, but we're here for the vibe. we're here for the vibe. Okay, so let's read through this one more time. Given the root of a binary tree, return the in-order traversal of its nodes' values. Okie dokie. So I guess we're using an iterative approach to this. And I think we should use a stack structure. So that being said, let's initialize some things here. We're going to have result because that's what you have to do. We're going to do stack, and we are going to do current, which is going to equal the root. Now, we want to, from here, traverse the leftmost node while pushing nodes onto the stack. So the best way I can think to do that is a little while diddly bit here of while current or stack, and then while current, then we stack append the current, which makes the current equal to the current left. So we just will traverse that to the leftmost point. And if you're confused about what I'm saying, the leftmost point is here. Like, this is your leftmost point. So we're going to say current left. Easy. I think from here, so given the root of a binary tree, return the in-order traversal of its nodes' values. So I know from here we also need to move to the right subtree. But once we reach the leftmost, we need to do what? Pop from the stack? Maybe? Yeah. Yeah, if we pop the last node from the stack, then we can go move to the right subtree. So let's say current equals stack pop. And then we're going to append those results to the current value. So we're essentially going to pop the nodes from the stack one by one, adding their results to the results list. And then we need to move to the right subtree and essentially repeat the process. So all I'm going to say is current equals current right. So that should be the iterative approach, I guess. I definitely, I don't know. That's fine. It's fine. This will be fine. Okay, so we initialize the result, stack current, which is the root. We then do this leftmost node, pushing the nodes onto the stack. Then we pop out the last node from the stack, and we move to the right of the subtree and then push out the result, which should, in theory, be the in-order traversal of the node's values. So, I don't think I'm missing anything. Because that should be an iterative approach. Maybe not, though. No, I think this makes sense. Because I think, honestly, this will save memory a lot versus a recursive solution. And maybe that's why they say that. Yeah, let's run it and see. We're 5 minutes into this question, so return is outside of that. Listen here. Listen, Linda. Listen. We got it. We got them, boys. Okay. I'll take it. Do I want to change anything? Do I want to change anything? I don't think so. This was actually easy. You know what? Knock on wood. This did require some brain power. Hopefully that'll make my result better. I know it's not going to, but ooh, okay, memory was better, but runtime was womp 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 womp. Only 32% of users that I beat with runtime. But overall, for like 6 minutes, I actually would love to see this as a recursive solution or a more streamlined iterative solution. But I guess I'm not too pressed about it. So I'm going to leave this code in my GitHub repo, which is linked down in the video description down below. You guys are more than welcome to fork and clone, make this better, make it worse. Actually, if you could, have some fun and learn something new, but also, if you could also maybe share with me your recursive solution for this and your iterative solution for this, I would love to learn how I could better optimize the 6 minutes I just did this in. And if there's a better solution than recursive or iterative, I would love to know that too. So feel free to drop that in the comments down below. I thank you guys so much for sticking with me. I am so excited to hit my 100th problem, which will actually be my 130th problem, because I did 30 days of the LeetCode, which I don't think included, or maybe I think it was like 127, because I think it had question 50 in there and question 63 or 65. But yeah, I want to thank you guys so much for coming with me on this journey. We're getting so close to the end of this first leg. I'm going to keep going. I'm trying to literally see how many I can do in a year, but 100 is a great place to start. 100 is a great jumping off point. So again, thank you guys so much for watching, and I will see you guys in the next video. Goodbye.